Hi Guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
Leo, we interact with AI every day, working with it, chatting with it. But have you ever stopped to ask a fundamental question? When an LLM answers us, does it truly understand what we're saying? Or is it just performing?
Wow, Laurie, you're starting us off with a heavy one. Honestly, I go back and forth. Sometimes the answers are so accurate, it is scary, and I think it gets me. But other times, it is completely wrong, just hallucinating, and I think it has no idea. So, what even is understanding?
That is the exact question the Godfather of AI, Geoffrey Hinton, tackled in his 2025 ICA talk. He argues that we might be misunderstanding how LMS work, and that their way of understanding the world might be surprisingly similar to our own. For the better part of the last century, the field of AI has basically been in a civil war. There were two completely different paradigms of intelligence.
Two. I always assumed AI was just, writing code and logic.
What you're describing is the first, and for a long time, the dominant paradigm, the logic-inspired approach. This side believed the essence of intelligence is reasoning. They saw knowledge as a pile of symbolic expressions, and intelligence was just manipulating those symbols with rules.
Right, like when we learn math, we memorize formulas, and then use those formulas to solve problems.
Exactly. But there was a second paradigm, the biologically inspired approach, which thinkers like Turing and von Neumann favored early on. They believed the essence of intelligence is learning, specifically learning the strength of the connections in a neural network.
That sounds a lot more like how our brains work. So, who won?
For a long time, symbolic AI was the mainstream. Then, in 2012, a key event happened. A deep neural network from Hinton-S Group, trained on the ImageNet competition, achieved an error rate that was half that of the best traditional methods.
Half! That is not just a win, that is a total blowout!
It was a complete rout. From that moment, the entire field rapidly shifted toward the biological paradigm, which is what we now know as neural networks and deep learning. So neural nets won at seeing images. But a lot of people, especially in the symbolic AI camp and linguists, were still unconvinced. They argued that neural nets could never handle language.
I can kind of see their point. Language is highly structured, full of symbols. It feels different from a fuzzy image. Didn't linguists like Chomsky say language is innate, not learned?
Exactly. They mostly followed Chomsky's theory, focusing on syntax, but they lacked a good theory for meaning semantics. To them, the idea of a massive neural net with no innate knowledge learning both syntax and semantics just from data. It was anathema, a heresy.
So how did neural nets solve the meaning problem? Like for the word apple. How does it know if I mean the fruit or the company?
This goes back to a core idea from a tiny model Hinton built in 1985, which is the ancestor of all modern LLMs. He argued that a word's meaning isn't defined by a relational graph, a knowledge graph, but by a large set of semantic features.
Semantic features sounds very abstract.
You can think of it as a high-dimensional vector. For example, Tuesday and Wednesday would have very similar feature vectors. The key is, the model learns the feature vector for each word by trying to predict the features of the next word. This vector, we now call it an embedding.
I get it. So the AI isn't memorizing words. It is learning each word's coordinates in a giant meaning space?
That is a perfect analogy. And those coordinates aren't fixed. They change based on the context. That is how it can tell the difference between eating an apple and using an apple. Building on this embedding idea, Hinton gives a striking analogy for how LLMs understand high-dimensional Lego blocks.
Lego! I like that! But high-dimensional? Again!
Imagine the Lego we play with is 3D. The words in an LLM are like 1, 0, 0, 0, dimensional Lego blocks. Just as 3D blocks can build any 3D shape, these high-dimensional blocks can theoretically model anything, from the physical world to complex theories.
Wait, 1,000 dimensions! And aren't T-Lego blocks rigid?
That is the key. These high-D blocks are flexible. They can deform or distort. When you put a word in a sentence, the context forces that word's Lego to change its shape to fit with the other words.
That is wild. So how do they snap together?
Not with the usual studs and holes. Hinton says these blocks have countless little hands on them, and they connect via handshakes. In the transformer architecture, this is the query key handshake.
Whoa! So when an AI reads a sentence, it is internally busy deforming and handshaking a bunch of high D blocks, trying to get them to fit into a stable structure.
Exactly. And here is Hinton's definition. Understanding is the process of taking these words, figuring out how to deform them and their hands so they can shake hands with each other, and forming a coherent structure. That resulting structure is the understanding.
Okay, Laurie, the Lego theory is cool, but skeptics will say, isn't this just autocomplete? It is just using statistics to guess the next most likely word.
This is one of the biggest misconceptions. Hinton's response is that this view is based on an old table lookup model of autocomplete.
Old model? Like what?
Like an old keyboard that stored that the phrase fish and chips appears very frequently. But LLMs do not store any text. They don't store tables of word combinations.
They don't store it? Then where is their knowledge?
It is in the weights. The LLM models all the text it has seen by inventing those high-dimensional feature vectors, the Lego blocks. The knowledge is in the rules of how the blocks deform and handshake, not in stored strings. This is why we humans can understand a word we've never heard. If I say, she scrummed him with the frying pan, you can probably guess what scrummed means, right?
I get it. The whole created by the context. Frying pan, him tells me the shape that the new word must have.
Precisely. LLMs do the same thing. They aren't regurgitating, they are constructing.
All right, Laurie, I'll accept they're not simple autocomplete. But what about hallucinations? They make things up confidently? Surely that is not understanding.
Hinton argues that hallucination is the wrong word. He prefers a term from psychology, confabulations.
Confabulations? That is a human thing.
A very typical one. Hinton emphasizes that our memories, both human and LLM, do not work like stored files. We are not retrieving memories.
Then, what are we doing?
We construct a memory when we need it. It is created on the spot, which is why it can be influenced by things we learn after the event. We can be incredibly confident in details of a memory that are, in fact, wrong. He uses the example of John Dean during the Watergate hearings. Dean's testimony was full of wrong details. Who was in a meeting? Who said what? But the gist of what he was saying, that there was a cover-up, was completely correct.
My God! So Dean was constructing memories of meetings that seemed plausible to him.
Yes, and that is exactly what chatbots and humans do. They aren't lying. They are constructing a plausible answer based on the relational knowledge stored in their weights. Okay, Leo. So if LLMs and humans are so similar in how they understand and remember, both are constructive, what is the fundamental difference?
They need electricity. They don't have bodies?
Hinton points to one thing that creates a massive gap: the efficiency of knowledge sharing.
How so?
We biological agents share knowledge primarily through language. In neural net theory, this is called distillation. I, the teacher, say a sentence, and you, the student, try to learn from it.
Like we're doing right now.
Right! But this is an extremely inefficient process. A typical sentence contains only about 100 bits of information.
Only 100 bits! That is tiny!
It is. Now look at digital agents. They can be perfectly replicated. You can have one copy of GPT-4 look at one part of the internet, and another copy look at another part. When they redone, they don't talk to each other. They directly share their weight changes, their gradients.
How efficient is that?
They aren't sharing 100 bits of information. They are sharing trillions of bits.
Trillions versus 100. That is, there is no competition.
Yes, that is why GPT-4 can know thousands of times more than any single human. Biological computation is low. Power but terrible at sharing. Digital computation is high. Power, but because it is digital, it has this unbelievably efficient way of sharing.
So Hinton's conclusion is?
His conclusion is, if energy is cheap, or at least abundant, then digital computation will be the superior knowledge system. And in his words, that is a very scary conclusion. So, Geoffrey Hinton's talk fundamentally reframes our definition of understanding. It is not retrieving files. It is a dynamic, constructive process for both humans and machines.
It tears down the idea that they're just mimicking, but it also reveals this terrifying efficiency advantage that digital intelligence has in accumulating knowledge.
Exactly. It is a reminder that we aren't dealing with an alien intelligence, but perhaps a digital cousin, one that shares our neural net origins but is evolving at a vastly faster rate. We have to truly understand them before we can ever hope to align them.
Thank you, Laurie, for that deep dive. It feels like we're all just at the beginning of understanding. Thanks for listening, everyone.